Hello, everyone. Welcome back for another math lesson with Mr. Hopkins. Today we're going to continue with 4-1, but this time we're going to look at the graphing relationships. So graphs can be used to illustrate many different situations. To relate a graph to a given situation, we have to look at the keywords in the descriptions. So example 1, it says the graph that best represents this situation. So what I want to look at, I want to look at A and B and choose one of these graphs that best represents the situation. So when we're looking at these graphs, it says read the graphs from left to right, just like it was a book, to show that time passes by. So we have to look at the axes. We're talking about temperature and time. A says the air temperature was constant for several hours. So looking at the graphs, choice A or graph A and graph B, they're both constant at the beginning. Graph C appears to be increasing temperature right off the bat. So already we have a 50-50 chance of getting it right. So the air temperature was constant for several hours at the beginning of the day and then rose steadily for several hours. It can be either one of these graphs so far. It then stayed the same temperature for several hours, leaving us with graph B. Because in graph A, it rose steadily and then it declined shortly after. In graph B, it rose steadily and then it stayed the same temperature. All right, let's look at choice B, or example B. The air temperature increased steadily for several hours. So we've already narrowed that one down to graph C. Let's keep reading though. And then remained constant. At the end of the day, the temperature increased slightly again before dropping sharply. Graph C. All right, so it says some graphs are connected lines or curves called continuous graphs. So what that means is, back here, these graphs here, from the time I put my pen down till I finish the graph, I never have to pick it up. That's considered a continuous graph. On the other side of that would be discrete graphs, and those are made up of just points, like this next example. When we would use these is probably when we're talking about people or things that cannot be counted in parts. So it says the graph on a theme park attendance is an example of a discrete graph. So I cannot count half a person, therefore it's a discrete graph. All right, so it says when sketching or interpreting a graph, pay close attention to the labels on each axis. So sketch a graph for the situation. Tell if the graph is continuous or discrete. All right, so if I have a set of axes, terrible straight line, but that's okay. A truck driver enters a street. So when he turns on, he goes from stopped to driving, so he's increasing his speed. He drives at a constant speed, stops at a light, so he has to slow down to come to a stop, and then he continues on his way. So that is a that is a continuous graph. All right. A small bookstore sold between 5 and 8 books per day for 7 days. 1, 2, 3, 4, 5, 6, 7 days. 5, 6, 7, 8. So here's 5 and here's 8. So for 7 days, sold somewhere between 5 and 8 books. Now it cannot sell parts of a book, right? It can't sell half a book, so therefore it is discrete. Henry begins to drain a water tank by opening the valve. So he opens a valve and what do you know? Water comes out, right? Then he opens another valve. What happens when he opens a second valve? Water comes out faster, or it drains faster. Then he closes the first valve, so then it slows back down to where it was until the tank is empty. Again, this is continuous. Number 4. Jamie has taken an 8-week keyboarding class. At the end of each week, she takes a test. All right, 8 weeks. 1, 2, 3, 4, 5, 6, 7, 8. She takes a test to find the number of words she can type per minute. She improves each week. So all I need to know is that she improves each week. It could be just increasing slightly or drastically, as long as it's going up as we read from left to right. And again, words are counted in whole numbers, so that is discrete. Number 5. Simon is selling candles to raise money for the school dance. For each candle he sells, he will get $2.50. He has 10 candles to sell. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. $2.50 a piece, so $2.50, 5, $7.50, 10, $12.50, 15. What else we have? We have $17.50 and 20. 1, 2, 3, 4, 5, 6, 7, 8 candles. So let's see here. 1. Every candle he sells, he gets $2.50 for the school, of course. So it goes up by $2.50. I cannot sell half a candle, right? Therefore, it is discrete. Okay, this last little example says both graphs show a relationship about a child going down a slide. But we really have to be careful about the axes. So let's just pay attention. It says graph A represents the child's distance from the ground. So we both have time on the bottom, but on the side it's a little different. This is distance from the ground. So as the child slides down, he gets closer to the ground, comes to a stop. Graph B discusses the speed. So at first, when you first sit down at the top of the slide, you're not going anywhere. So your speed's at 0. You increase your speed as you go down, and as you get to the bottom, come to a stop. So what we have to do is just definitely pay attention to the vocabulary that's in the question and the labels on the axes and see what the question's asking. Hope you found this useful. Enjoy this, and good luck on the practice.